Hi everyone, in this video we're going to be talking about the physical properties of solutions. So what you can have with you can either have out your notes, which I have here, alongside your packet of fun, or you can simply just have out your packet of fun and follow along with me. So first off, physical properties of solutions will change based off what is dissolved in something else. So for instance, the conductivity of a solution might be present or not be present. And it just depends on whether or not, I'm actually going to bring the notes back here. It depends on whether or not something is conductive in solution. So I want to remind you guys how something conducts. Something is conductive if there is a flow of a negative charge. So it says here, conductivity is the ability to conduct an electrical current, and it's found in some solutions. For a substance to have conductivity, it must have a charged particles that can move freely. You guys learned in our ionic compound chapter that something is conductive, that ionic compounds can be conductive if they're dissolved, but, so you can see NaCl dissolved in water is very conductive, but a solid chunk of NaCl is not conductive. So basically, when something dissolves, if it forms free-flowing ions, then it is conductive. If it doesn't, then it is not conductive. So we're going to be comparing an ionic compound to a sugar compound today. So I'm going to go back to our packet of fun here, and we will take a look at this word called electrolyte. So an electrolyte, those are substances that when dissolved in H2O provide ions that are charged atoms, so positive or negative ions that can move around freely. Right? So I would need you guys to write that down in the area there. So substances that dissolve in H2O in water and provide ions that flow freely. So if you think about where you've heard this word before, electrolyte, a lot of times you've heard them in sports drinks. And they are in sports drinks. And after playing a really hard sport, or maybe running, or after practice or anything like that, people are like, oh, make sure that you drink a Gatorade or a Powerade or replenish those electrolytes. That's because when we sweat and we work really hard, maybe it's during strength training or running, when we sweat, our sweat also has salt in it. So we lose a lot of those salts. Now, if you remember, the term salt is used as an ion. It's used for an ionic compound. So the fact that we are losing salts along with our sweat or the water coming out of us, we're losing electrolytes. Therefore, we have to replenish them. So in sports, we have sports drinks. I'll just put drinks have electrolytes. And some examples would be like sodium electrolytes, or maybe potassium electrolytes, maybe magnesium. Those would all be in sports drinks that would help replenish the ones that we've lost. Now, think about that word in and of itself, electrolytes. So electrolytes are substances that when dissolved, they form freely flowing ions. And why are they called electrolytes? Because they are able to conduct electricity because you have this free negative flow. Okay, so because we have this free flowing negative anion charges present, then they're able to flow and conduct electricity. Okay? So anything that, when dissolved, forms ions, so basically any ionic compound is going to form an electrolyte if it dissolves. Okay? So here we see the term strong electrolyte versus weak electrolyte. So I'll explain that really quick. A strong electrolyte is one that dissociates completely into ions. It dissociates completely into ions and conducts electricity well. What this means is that every single ion breaks apart from its other ions. So all the cations separate from all of the anions. And I'll show you another picture in a second to explain this. A weak electrolyte is one that does not dissociate completely into ions. So only some of them ionize. You have a couple ions that separate from each other, but some of them stay together as well. That's called a weak electrolyte. Now, a non-electrolyte are substances that, when dissolved, they do not allow electricity to flow. So we can write that down. Substances that do not allow electricity to flow. Substances that do not allow electricity to flow when dissolved. Now, in what circumstance would a substance not provide ions when it's dissolved? Well, that's if it's a covalent compound that dissolves. For instance, water is polar and sugar also has polar portions in it. But when sugar dissolves, those molecules are simply separating from each other. They are not dividing up into separate ions because originally they were just polar covalent. Now, because you don't have something separating into individual ions, there's no flow of electricity, and then you have a non-electrolyte. So I'm going to add something to our little definition here, and you can add it too. We can write that the substance does not provide ions. It does not provide ions when dissolved. So this would be like any polar molecule, or maybe a nonpolar dissolving in a nonpolar molecule. It would not conduct electricity because it doesn't form free-flowing ions. Now there are a couple of pictures at the bottom of your page here. And I just want us to go through whether it's an electrolyte versus a non-electrolyte, strong or weak, and why, and all that jazz. So we'll take a look at this first one. So here in this first image, we see that there is a light bulb that is lit up, which means that whatever solution it is in is conducting electricity. So this is definitely an electrolyte. And if you take a look, all of the sodiums and the chlorides, they're all separate from each other. This one would be a strong electrolyte. And that is because this fully ionized. Our next one, here we see, oh, this one's an interesting one. We see the light bulb semi-lit. It's not as bright as the previous one. And where the sodium and chlorides were separate, we have the hydrogen and fluorides that are separate, but not all of them are. So we see a weak electrolyte here. And the reason being is that there was only a partial ionization. So this one, partially ionized. Now our last one, we have sugar dissolving in water and the light bulb did not ignite at all. The reason being is sugar is C6H12O6. It is a polar covalent compound. And so here we have a non-electrolyte. And what's happening when sugar dissolves is that the sugar molecules separate from each other, but the molecules themselves do not. So you don't ever end up having positive and negative ions that are in the water. You still have full sugar molecules. The molecules are just separated from each other. Versus over here, you actually had the ionic compound divide up into separate ions. So again, if something breaks apart into ions, it can either be a weak electrolyte or strong electrolyte, depending on if something fully ionizes versus partially ionizes. And for our non-electrolytes, it's any polar covalent compound that dissolves, but it does not break apart into ions. What I'd like you guys to do is now come down here and decide which one of these would be electrolytes versus non-electrolytes. And have a great day.